Today, we are going to be talking about how Earth's climate system works and why climate changes. But before we get to the physics, chemistry, and human activities that drive climate change, I want to introduce an analysis and argumentation technique. For each statement, we can identify a logical part and a factual part, and then identify whether these are true or false. For example, the statement, today is Monday because yesterday was Sunday, may be factually false. Perhaps yesterday was not Sunday, but it is logically correct. Monday follows Sunday. We can evaluate the second statement similarly. The moon is made of cheese because I read it in a book. This statement could be factually true, but just because you read it in a book does not necessarily make the statement true. This is called an argument from authority and what we call a logical fallacy. Logical fallacies are statements that are logically false, regardless of whether they are factually true or not. They tend to follow specific formats and structures, and I've listed some examples here. Some of these you may be familiar with, things like an appeal to fear, a non sequitur, a straw man, ad hominem, argument from authority, slippery slope, false analogy, false dilemma, paralysis analysis, and moving the goalpost. Knowing the logical fallacies can be helpful when evaluating the validity of a source or a statement. The reason I'm introducing you to logical fallacies now is that they come up a lot when people are talking about environmental issues, particularly climate change. Sometimes people use logical fallacies without realizing it because they don't really understand the subject they're talking about. And sometimes people use logical fallacies when they're trying to sway your beliefs or opinions, even though the facts aren't on their side. So, as we proceed through the next few weeks of class and think about various climate statements and whether they are logical fallacies, you can use this chart to help assess factual and logical validity. All right, let's evaluate a climate statement. July 2022 was hotter than 2021. That means the globe is warming. Is this statement true or false? It's a false statement, even though both parts of it are factually true. It's a false analogy. Just because July 2022 was hotter than 2021 doesn't mean that the globe is warming. To understand why it's a false analogy, we need to understand the difference between the terms weather and climate. Weather is what we observe right now, right outside your window. We experience weather on the scale of hours to days to months. But climate is defined as the 30-year average of weather observations. So we're talking about climate being something on the order of decades to centuries. This distinction is important because longer term averages like climate are more meaningful than individual observations and better show changes over time. When scientists talk about climate change, they are referring to the longer term changes in climate rather than, for example, temperature on any given day, week, month, or even year. Another way of thinking about it is that climate is the clothes in your closet, and weather is the clothes you wear today. In between weather and climate, we have what we term climate variability. Because of huge regional and global changes in the way the ocean and atmosphere move heat around, we have some years that are warmer than others, some years that are rainier than others. This is part of natural climate variability. If long-term climate isn't changing, we'd expect those warm years and cold years and wet years and dry years to even out over time and give us the same climate over decades to centuries. But with climate change, the wet years get a little wetter or the warm years get a little warmer. And so our average state over those 30-year periods and longer is shifting over time. And that's what we call climate change. So if we want to look at data that tells us about climate, we already know that we need many years of data. That way we won't get lost in the noisiness and variability of weather or of climate variability. Sometimes it's also nice to think about comparing our data over time to some sort of baseline or normal condition. In this graph, we're looking at how temperature changes from 1880 to 2020 on a global average basis. The scientists have calculated what the average temperature of the 20th century is, and they've called that zero on this graph. Years that are colder than average are blue bars pointing down, and years that are warmer than average are red bars pointing up. If climate wasn't changing, we'd expect blue and red bars to appear in about even numbers the whole time from 1880 to 2020. But that's not what we see. We see all blue bars, colder than average, temperatures before 1940, and all red bars, warmer than average temperatures since 1975. And those warm red bars keep getting higher and higher. That's how that we know that we are seeing a signal of climate change. Well, we can't use a few days, months, or years of weather to tell us about climate change. There is a linkage that goes the other way. As the Earth's average temperature warms up, we're more likely to have more hot weather and less cold weather. So if we look at this graph, we see that in the past, our average temperature might have been around here. As that average or climate shifts warmer, so does all of the variability that we get with weather. So as our average temperature shifts warmer, we're going to be less likely to have super cold weather and more likely to have more hot weather and even more record hot weather.